Hello, my name is Gary Swiney, and this is my review of CSE 546 Homework 2. So first, let's start with the code review, where we are asked to run k-fold cross-validation, as well as the respective algorithm on the test set. So here we are generating the graph of the performance of the folds as we vary C for SVM, and this graph is for the as we vary C for SVM without k-fold. And we can click on this box up here and run it to show that it works, and it'll just take a moment. Now this one takes less time to run than compared to linear regression, which we won't even run today because it just takes way too long. It took in the hundreds of seconds in order to calculate, and that's just way too long for this video. But that one by far was the most expensive in terms of time. So as you can see, we got our outputs here, our best training score and our testing score, which we will talk about later. So let's just show that this code runs. Here is our code for linear logistic regression, which is the same setup where we are running k-fold, capturing the best score, and then running the algorithm again with the test data set to compare against it. And this one again we won't run because it takes way too long. And then here is our k nearest neighbors, which doesn't take too long at all, and again it follows the same process of running k-fold and trying different values of k and recording the best responses for each. As we can see, each of these code blocks spits out two numerical values for us to remember, which it captures the best training score at a user varied parameter and the best testing score at a user varied parameter, which we will use to discuss later. And as we can see, they spit out the same graphs that we will be using in our report. So now we can move over to the report, and I do not like when it sets it up like this. That's okay. We can do a half screen. As soon as I can grab the box, wow. Okay. So in this lab, we are again analyzing the difference of k-fold performance versus their respective algorithm in terms of test score. And the point of k-fold is to prevent over and underfitting by randomizing sets of the data and performing training and testing on all of them and creating a mean value of which to give more reliable responses. So in our analysis here, we started with SVM. We can see an area of underfitting as the graph approaches a plateau, and this is what I would say is the sweet spot, right around 0 to 10 to the negative 3. And then we can see still high performance, but some variation in response where the data is becoming a little overfit. And in this area of fluctuation, as we can see, is where our biggest possibility of a misclassification may be. Now, when comparing the mean performance of SVM k-fold and SVM by itself, we can see that it's pretty similar, but when referring to figure 1c, we can see that testing performed a little bit better than the k-fold training set. And the k-fold training set found a c-value peak way higher than the testing did, possibly due to becoming overfit and those fluctuations. In logistic regression, again, this one was the hardest of all to run. It took the most time. If you please look at the y-scale, you could see that even though these fluctuations appear big, they are super small in terms of accuracy. So here we can see an area of underfitting as the values are for SVN and linear regression both. Whenever we are underfitting, that means there's too much regularization going on, and as we can see increases. We could find the sweet spot with some of these k-folds even getting as high as we're getting a 1 accuracy score. And then as the data becomes overfit, we see way too many fluctuations as the data is becoming too sensitive on the test set. The data is becoming too sensitive, and it's not reliable in this case, where it is overfit. And we can see the same sort of performance happening in figure 2b for the test set of linear regression. But as we can see in figure 2c, even though figure 2b found a fluctuation that was higher than the plateau in figure 2a, figure 2a still, in my book, has the best and most responsive performance in this area. Despite 2b, it almost seems getting lucky with a fluctuation as soon as it starts getting overfit in that area with a score. And in KNN, here we can see, again, please look at the y-axis, this data is very, very accurate still, but there are large fluctuations in response to it. Yet, I want you to note something. Here, the nearest neighbor's highest value of accuracy is found in figure 3a at k equal to 4. But in the normal test set response, it is found at k equal to 1. Now, I think that is, you can see these big variations for k nearest neighbor is because the data is split into 5 folds that have much less data entries. There's going to be high variation in their nearest neighbor performance. Yet their averages remain very close, and as the data becomes overfit, it's entirely consistent. So towards, even though the highest performance is here, and after the major performance we're becoming overfit, it is still entirely consistent, as you can see by these long straight lines of little variation. Sort of where k-fold is minimizing that factor. But in the normal performance, we can see the highest response was at k equal to 1, yet as the data became overfit, there's a lot more fluctuation in it. And we can see that the data is overfit after the peak as well, and a little bit more so than the average of the k-fold. And that concludes our analysis. And in terms of training score, which is our k-fold, we could say that linear regression or logistic regression has the best performance in terms of k-fold performance, which is what we were analyzing today, with a response of 0.999 at its peak around c equal to 0 here in this range on this graph, is about our best performance out of all the k-fold responses. But again, this was the most expensive algorithm, as it took absolutely the most time to run, likely because the number of entries in C. But again, due to k-fold, there is some multiplicity there in terms of how many calculations it's doing. And yeah, that is absolutely it. Thank you so much.